Hello students, today we are going to discuss about digital to analog converter. The circuit which is shown in front of you is a 2-bit R to R ladder digital to analog converter. Here for this operation we are going to use LM358 IC, and this is a 2-bit digital to analog converter circuit is designed over here. As we know that we are using a R to R ladder network. So here we are connecting the resistive element R, and here these resistive elements we are connecting are 2R, means only two values of resistors are required, and this is the basic advantage of using R to R ladder digital to analog converter. The R value we have selected is 1 kilo ohm, and that's why 2R is nothing but 2 kilo ohm. The values or the digital inputs we are going to apply is a 5 volt. So if the switch is connected in this direction, 5 volt supply will get applied connected over here, and if switch is connected over here, means this connection corresponds to ground. So the digital input you are going to apply will be either 5 volt or 0 volt, and correspondingly the output will be set by the amplifier over here. That is digital input signal gets converted into corresponding analog signal at the output side. The digital input is nothing but you are going to set the input signal as either 0 level or 1 level. That is 0 means 0 volts and 1 corresponds to 5 volt over here. If we see the observation table, what is expected theoretically, if you consider that digital input, these are the digital inputs we are going to take. These are the digital inputs A0 and A1. Here we applied a 5 volt signal, and operational amplifier supply we are going to apply as usual, plus minus 10 volt we are applying. This A0 and A1 values we are going to set at the 0 level or 1 level, means we are going to apply here either 0 or 5 volt signal. And by considering this, the observation table is like this. Whenever we are going to apply 0 0, means A1 as well as A0 both are connected to ground potential, theoretically the output voltage will be 0. When A1 is connected to 0 and A0 is connected to 1, theoretically output is minus 2.5 volt. Whenever A1 is 1 and A0 is 0, the output is minus 5 volt. When both A0 and A1 are 1 1, theoretically output is minus 7.5 volt. The output signal minus value we are getting because the input signal which we are going to apply is connected to pin number 2, that is the inverting terminal of the integrated circuit. So working is happening like this. Whenever this, we suppose, is connected to 5 volts, this is 2R, this is 2R, means these two resistors are in parallel, and that's why whenever 5 volt get divided here at the 2.5 volt, and correspondingly at successive voltage successive stages, by application of a potential divider, the input voltage gets applied to the amplifier, and correspondingly it will generate analog signal. Remember one thing, both A0 and A1 both are connected to 5 volts. At that time, the effective output voltage we are getting is a minus 7.5 volts theoretically. In this way, this digital input which we are applying as 0 0 0 1 1 0 and 1 1 correspondingly gets converted into the steps of 2.5 volts, 0 to minus 2.5, minus 5 and minus 7.5 volts theoretically. Now let us come to the actual circuit implementation. This is a dual power supply. As I mentioned, to this IC we have LM358, we are going to apply dual power supply. So this is a plus, this is a minus, and this is ground. We are using this dual power supply section of our power supply. On a circuit board, this is a plus, this is a plus, this is a minus, and this is a ground connection. Here between these two terminals we are going to apply 5 volt supply. Between these two terminals 5 volt supply is connected, and between these two terminals we are going to take the output which is taken on a multimeter. These are the two wires we are going to take. So these are the two wires available. This is a A1 terminal and this is a A0 terminal. Right now these terminals are not connected anywhere. We are going to connect these terminals, means A1 and A0 we are making 0 0, means we are connecting to ground potential, then either to 5 volt supply or ground continuously we are going to take, and then we will observe the output voltage. We will see the output voltage when both are connected to ground initially. Remember, theoretically when both are connected to ground, the output voltage is expected as a 0 volts, and practically if you will observe the results, you are getting minus 14.1 millivolts, means we are getting the result nearby the theoretical value. Theoretically 0 expected, and practically we are getting minus 14.1 millivolt signal. Whenever we are connecting A0 to 1 and A1 we are connecting A1 is connected to 0 and A0 is connected to suppose 1, that is A0 is connected to 5 volt signal, that is one level, where theoretically we are expecting the output voltage should be 2.5 volts, and practically we can see minus 2.57 we are getting, means again we are getting the results at a theoretical values. Now if we are going to take A1 is equal to 1 volt and A0 equal to 0, theoretically we are expecting to get the output voltage as a minus 5 volt, and practically we are getting minus 5.13 volts, means again for this case also the analog input voltage corresponding to digital input signal is obtained as per the theoretical values. Now I am connecting A0 as well as A1, both are connected to logic 1, and theoretically we are expecting the output voltage to be minus 7.5 volts, and practically we are getting minus 7.68 volt, means theoretical and practical values are mostly matching with each other result. Hence the conversion of digital signal to analog signal is obtained in this case. This is the objective we are defined that design a circuit for R to R ladder type of DAC, digital to analog conversion, and hence we have achieved the result for 2-bit R to R ladder DAC. Thank you.